we're looking at section 13.2, exponential decay functions. So these decay functions are going to act very similar to our exponential growth functions, except instead of increasing values, our values are going to be decreasing. So now we're analyzing the functions of 1 over 2 to the x and 1 over 10 to the x. So this time if we're taking 1 over 2 to the negative 3, we have to switch the base if we take a negative exponent. So 1/2 to the negative 3 power is the same thing as 2 over 1 to the third power. So that's why we're getting a value of 8 here. We get 4 here, 2, 1, and then 1/2, 1/4, and 1/8. Similarly down here, we'll get 100, 10, 1, 1 over 10, 1 over 100, and 1 over 1,000 for the values here. So you'll notice this time, if you graph these, the end behavior appears to go to 0. Our values are decreasing this time. So our domain on each one is going to be all real numbers, negative infinity to positive infinity. Our range is still y greater than 0. The end behavior, as x goes to infinity, our f of x, our values are going to be going to 0. As x goes to negative infinity, our functions are going to be going to infinity. And as happened in the last time, they both have the y-intercept at 0, 1, because anything to the 0 power is still 1. Though these times these functions decrease, we want to think about which one decreases faster. That would be the 1 over 10. Bigger number is going to decrease faster. So if we look at that table of the properties, what do we notice? They're all the same. All of the properties are the same. Domains are the same, the ranges are the same, the intercepts are the same. So if we're applying these changes, combined transformations, we still have similar things happening as what we've seen before. The only main difference is the reference points. We still have the reference point 0, 1. That hasn't changed. We still have an asymptote. Starts out at y equals 0. The second reference point is going to be a little different. Before it was 1b. Now it's going to be negative 1, 1 over b. Or if you think about it, it's going to be negative 1, comma. It's whatever your denominator is. Denominator. Because if you've got the function 1 over 10 to the x, your 1 over b would be 1 over 10, which is the same thing as just 10. So your second reference point would be negative 1 and then comma whatever your denominator of your base is. So same types of changes are happening. In the exponent, it's affecting the x values where you're moving left or right. Your k is outside the function. It's your vertical shift. And then a is your vertical transformation, your stretch or compression, and then if it reflects. So here we have our a value is 3. Our base is 1/2. Our h value is 2, and our k is negative 2. So the original coordinates be at 0, 1, and then at negative 1, 2. Okay, you can see that here. So those are what are being transformed with those parameters. So we had the wrong graph here, but we can figure out what's happening. I like to see what's changing in our coordinates. So our x values, we will need to subtract 2 because we're moving left 2. Our y values will multiply by negative 1 and then add 8. So our coordinates would be 0, 1. So that will change to become negative 2, 7. And then our other reference point is negative 1, 10. Remember, it's the denominator of your base there. And it would change to become negative 3, negative 2. So our asymptote would be at y equals 8 because we shifted up. Domain is still all real numbers. Domain is all real numbers. And then the range, we did reflect. So y will be less than our asymptote at 8. So which parameters make the domain and range differ from those of the parent function? The domain doesn't change. Domain is always going to be all real numbers. The range. The range is going to be y is greater than the asymptote if a is positive. So if we're multiplying by a positive number, y will be greater than our asymptote. Y will be less than our asymptote if a is negative. If a is negative, that means we're multiplying by a negative number. We're going to have a reflection. So our y values will be less than our asymptote. All right, so looking at what we got here, we're going to see how our coordinates are going to change. So our x values will need to subtract 2, y values will multiply by 3, and then subtract 4. So coordinates are 0, 1. That's going to change to -2, -1. Our other coordinate is at -1, and then our denominator of our base. So -1, 3, and that's going to change to -3, 5. We'll have an asymptote at -4. Domain is all real numbers. Range, we're going to say y is greater than -4. So we draw our asymptote at -4, coordinate at -2, -1, and at -3, 5. 3, 4, 5. There it is. So our function is going to look something like that. Okay, so writing the equation, this is going to be a little more challenging than the last time. So we still look for the asymptote. That's still telling us what our k value is. We still look at the point closest to the asymptote to find our h value where we shifted. Then to find your a value. So a plus k is the y value at the first reference point. So that's the one that's closest to the asymptote. And then to find your b, your denominator of your fractional base, you have to use the second one now. So a over b plus k is going to be the y value at the second reference point. So that's the one that's further away from the asymptote. So if we see what this looks like, our asymptote is at -1, so our k value is -1. So the first reference point, the one closest to the asymptote, is at 2, -1/2. So that's telling us that our h value is 2. So then our the y value there, which is -1/2, is going to be our a plus k. So that means a minus 1 is -1/2, which means a will be +1/2. So a is +1/2. So then we use the other reference point at 1, 4. So that's going to be a over b plus k is the y value there. So a we already know. A is 1/2 over b plus our k value of -1 is the y value there, 4. So 1/2 over b is 5, and b will end up being 10. So that's the denominator of our fractional exponent. Fractional base is going to be 10. So our function then, our a value is 1/2. So 1/2 times 1 over 10, our b value, and then x minus 2, our h, and then minus 1 for our asymptote. Domain is still all real numbers, and then our range, y is greater than -1. So trying another one, we've got the asymptote at -4, so that means our k value is -4. The point closest to the asymptote is at 1, -2, so that means our h value is going to be +1. If you come back for the next video, we will hopefully get this lesson all finished up.